So how are the risks changing with for increasing levels of global warming for some of the systems that we are talking about? So here are global surface temperature change increase relative to the period 1850 to 1900. Base periods can change the relative amounts, but the message doesn't change that much at all. So here we are looking at the anomalies with respect to that base period for various scenarios, projections for different scenarios. SSP1 1.9, so basically this is shared socioeconomic pathway 1, which is towards sustainability and I think low challenges to adaptation and mitigation. 1.9 is the radiative forcing resulting at 2100 as an imbalance corresponding to RCP, representative concentration pathway. So these are combinations of shared socioeconomic pathways and radiative forcings. So you know how that works. We have discussed it briefly. RCPs tend to focus on population, renewable energies, bioenergy and carbon capture sequestration, policy options, and so on and so forth, whereas SSPs are focusing more on socioeconomic choices of sustainability, business as usual, conflicts, and so on and so forth. Okay, so without going into those details which we have discussed elsewhere, obviously SSP 5 8.5 is basically business as usual scenario where we don't do very much at all. So you can see that the historic emissions with their dips related to volcanic eruptions and other things will continue to grow into the range of 4.5 to 5 degrees centigrade by 2100 for the business as usual scenario, and slowly we can bring it down with SSP3 7.0, SSP2 4.5, which is middle of the road scenario. SSP1 2.6 tries to keep us within 2 degrees C global warming with a 66% probability by 2100, and SSP1 1.9 keeps us below 1.5, which is right now seeming quite difficult because we are only behind in terms of where we should be as far as emissions reductions and drawdowns are concerned. Okay, so reasons for concern, RFCs, impact and risk assessments assuming low to no adaptation. So here is the risks: very high, high, moderate, and undetectable for various systems with various levels of confidence, which we cannot ignore. So we have to always say how probabilistic our information is, especially for future projections. So 1 dot to 4 dots go from low confidence to high confidence, and here are the historical range, historical average temperature increase in 2011 to 2020, which was 1.09 degrees centigrade with respect to this base period, ranging with the error bound of 0.95 to 1.2 degrees C. So that's where this change happened here. So you can see that we are very, very close to hitting the 1.5 degree target. So the systems looked at in terms of reasons for concern, 1 through 5 are unique and threatened systems, so systems which are confined to small places because of their dependence on environmental factors or climate niches and so on, and species that are threatened in various ways. So you can see that it hits very high risk very quickly, even at low levels of warming. And extreme weather events, again, we have a little bit of room in terms of moderate risks, but very quickly with the other scenarios here we're going to get to very high risks. Distribution of impacts in terms of how regional effects begin to spread over scales depends. So the confidence levels you can see here are low as we go from here, which is already kind of high. So these are very high here and high here, for example. This begins to get into end of medium confidence. So global average aggregate impacts, so confidence is medium, but you can see that the risk can be high. So one has to choose as a global community versus regional impacts. What are the investments we're going to make in terms of reducing the risks? Can we afford to delay action thinking the confidence here is low? Large scale singular events, again, you can see that the risks are moderate to high and remain so for a while in terms of the warming, but you can see it gets high as well. So all the systems with reasons for concern have high risk by with the increased warming and the scenarios, which at least gives you a sense that we probably do not want to go beyond this particular scenario here of SSP 2 4.5, and the lower we stay the better in terms of the risks, no matter what the confidence levels are. Looking again at impacts and risks to terrestrial and freshwater ecosystems in terms of global surface temperature change and in terms of various systems, biodiversity loss, structural changes in ecosystems and freshwater, terrestrial and freshwater systems, tree mortalities, wildfire increases, and carbon loss from terrestrial and freshwater ecosystems. Already there is some reports saying Amazon has become a net source of carbon because of deforestation and other forest degradation activities, and that's not good news, right? So here again is our warming from 2011 to 2020, and you can see again pretty much everybody with some level of confidence is going to hit high risks with the maximum warming scenarios that we looked at. Impacts and risks to ocean ecosystems: warm water corals, kelp forests, seagrass meadows, epipelagic rocky shores, and salt marshes. Again, the confidence is high for warm water corals, and very quickly, even at 1.5 degrees, the risk is going to become high, whereas kelp forests seem to have more tolerance, so confidence is fairly high, and they can stay okay with medium and low risks up to 3 degrees centigrade or so, but by 4 degrees they are hitting high risks again. Similarly, seagrass meadows, epipelagic, which means upper water ecosystems, rocky shores, lots of important species of shellfishes and so on that are in the rocky shores, and salt marshes, which are natural ecosystems with lots of co-benefits, also have somewhat high tolerance compared to warm water corals. So corals need immediate attention, and a lot has been said about this already. Okay, I think this is the last one in this category. Climate sensitivity, climate sensitive health outcomes under 3 adaptation scenarios. So again, global surface temperature change here, looking up to 4 degrees with some exceedances. So here we looked up to 4 degrees and we had some scenarios going up to 5 degrees. So we can look at health related morbidity and mortality, ozone related mortality, malaria, which is a serious killer still, unfortunately, especially in African countries and South American and Asian countries, dengue and other diseases carried by species of Aedes mosquitoes. So there is a direct impact on pathogen survival, mosquito breeding, human exposure, and vulnerability. So all these things are included. So mortality projections include demographic trends but do not include future efforts to improve air quality that reduce ozone concentration. So population projections remain quite controversial or uncertain, with many arguing that with education of women, population is already dropping seriously in many places. You know, China cancelled its one-child policy and is trying to encourage women to have children and so on. So with limited adaptation, again, confidence level here, where we are going to get into high risks for heat-related morbidity and mortality. Incomplete adaptation is going to bring us bad news at 3 degrees itself, and proactive adaptation can bring us to low risks and medium risks very quickly, obviously, if we can keep the surface temperatures to global mean of 2 degrees by 2100, and here the confidence is very high. Similarly, for ozone-related mortality, limited, incomplete, and proactive adaptation. With high confidence, we can say proactive adaptation will protect us very well and keep our risks very low for ozone-related mortality. And this is not even including efforts that could be separate for improving air qualities, like switching to renewable energies, decarbonization, net zero goals, and so on, are all bound to improve air quality. So that may additionally reduce the risks here. Malaria, limited adaptation and incomplete adaptation are not good news, but at least some adaptation will help. But you can see that proactive adaptation here brings us quite confidently to low risks, and losing a couple of million children to malaria every year is just completely avoidable if we do proper proactive adaptation. Dengue and other diseases carried by species of mosquitoes, Aedes mosquitoes. So you can see limited adaptation keeps these very high. If you look at 2022, for example, January in Delhi, dengue should be very low, but the unseasonal rainfall and the unusually warm nighttime minimum temperatures this year created serious number of dengue fever cases in Delhi in January. Is this a trend? Is this an anomaly? Is this going to become more frequent? These kinds of things have to be worried about, but you can see that with some confidence we can say this risk is going to be high if we don't do some at least limited adaptation. But even incomplete adaptation can reduce that risk because the warming will be lower, and of course with very high confidence we can bring that risk to manageable levels with proactive adaptation. So I will stop this podcast here, and we'll come back and look at the final bit of what the AR6 Working Group 2 report on impacts, adaptation and vulnerability has to say in terms of the regions and various levels of warmings. Okay.